Hello, PreCalculus students. We are going to talk about section 5.1 regarding trigonometric identities. And this video is going to be done in two parts. First part will be examples 1 through 4. So for those who are not here in class on Tuesday, April 18th, which is about half of you, maybe you took an extended spring break, I don't know. But we're going to do that. And then there'll be another video that covers examples 5, 6, 7, which is actually part of homework. Even if you were in class, we didn't go over those examples, but it's good to have a video so you can watch that and then do the homework problems associated with them. So we're only going to do the problems that have example whatever next to it, not homework whatever next to it, because of course homework is homework. It should be done at home. Even though I did let you guys work on it yesterday in class. But let's talk about the example 1 here. Secant x cotan x equals cosecant x. What you want to do is choose one side to work on and choose a more complicated side. And usually you want to convert any non-sine or non-cosine function to sine or cosine. For example, the left side looks a little more complex than the right side, so I'm going to choose to work on the left side. So we'll keep the right side intact. Secant we know is 1 over cosine x, which is actually shown in your notes. And cotangent is cosine x over sine x, which is also shown in your notes. We did explain in class why those are true. If you're not sure, because I don't want you just memorizing, do come and talk to me. I will give them to you, but it's always good to understand why cotangent is considered cosine over sine and why secant is considered 1 over cosine. Well, those cancel, of course. So you get 1 over sine x equals cosecant x, or cosecant x equals cosecant x. And now it's verified. That means that we've proven that the left side equals the right side. And an identity also, keep in mind, is not an equation. There's nothing to solve since an identity works for all real numbers for x. So whatever your input is, x is our input, whatever you plugged in, the left side will equal the right side. And we'll actually have another discussion about that later in the video. But it's not an equation, mind you, even though you do see an equal sign. It's actually two expressions that are equal to each other all the time, regardless of what you plug in for x. But we just have to verify it because they do look different initially, and then we make them look the same. Hence, an identity, right? You show that they're identical. Hopefully that makes some sense. Actually, we'll have that discussion right now. So this is an equation because you're solving it and you actually get just one answer. But this is an identity because this and this are identical, and you prove they're identical by doing a bit of algebra, right? If you distribute the 5 into 3x plus 2, combine like terms, you do get 15x plus 6. Let's look at another trigonometric identity. This side's clearly more complicated, and tangent can be converted to sine over cosine. Cosine is just itself, but I'm going to write as cosine x over 1. You'll see why in a sec. And of course you have secant x. Sine x by itself, I'm also going to write sine x over 1. Now the reason why I wrote sine x as sine x over 1 and cosine x as cosine x over 1, first of all, anything divided by 1 is itself, but also we're going to use a little fraction arithmetic here. When you multiply two fractions, like sine x over 1 and sine x over cos x, you just multiply numerators and denominators straight across. And of course, we have two fractions that are being added. You find the least common denominator, which in this case is just going to be cosine x. So we need to multiply this fraction I'm working with right now, top and bottom by cosine x, so the denominators become the same. And of course, they will be the same, because you're going to have sine squared x plus cosine squared x over cos x. So basically I've now combined both of these fractions because they have the same denominator. And this is very important to note. This is one of the other identities in the first sheet, is the Pythagorean trig identity, which is true because it would follow Pythagorean theorem, and that's going to be 1. If you weren't here for class, I'll explain again why that's true. Just ask me about it. I'll give you another explanation why sine squared plus cosine squared equals 1. Know that. It's very important. Again, I'll give it to you, but it's always good to understand why these work the way they do. So then you get 1 over cosine x, and 1 over cosine x is secant x. So you have secant x equals secant x, and boom, verified. Let's look at example 3. Sometimes you want to use a bit of algebra. So like, for example, I could factor out a cosine x. So do consider factoring if you can. And if you factor out the cosine x, you get this. And just because I'm lazy, I'm going to put double quotation marks because I don't feel like writing the right side over again. And by the way, this means you have 3 cosines being multiplied together because it's cosine cubed. Now, we know that 1 equals cosine squared x plus sine squared x. We also know that if we move things around a little bit, 1 minus sine squared x is the same thing as cosine squared x. Oh, look at that. Cosine x times cosine squared x is cosine cubed x. And boom, verified again. So again, we're just doing some manipulations to show that one side equals the other side using all the identities or tools that we have at our disposal. And then lastly, example 4, before I do the second part of the video. It's not quite clear which side is more complex. So here's what we're going to do. If I work on the left side, for example, I can actually separate the fraction in this manner. There's no harm in doing that because if I added those 2 fractions, I'd get back to the same place. And of course, that's secant x, and that's tan x, and we're verified. Or I could work on the right side and keep the left side intact. So this is, of course, I'm doing the left side. And of course, this is the right side. I can convert secant to 1 over cosine x and tangent sine over cosine x. And if I add those 2 fractions together, oh, look at that. They're the same. So also that is verified. So, that's a couple ways you can do it. Sometimes it's not clear which side is more complex, so you can work on either side, but you're going to have to do some sort of algebraic manipulation and substitution to make this work out. Okay, that concludes part 1 of this video.